Since the time where the first computers appeared, people began to form their ideas and imaginations in a virtual world. Beginning with simple games, this has evolved to almost realistic environments. Now it's time to come back to reality. Imagine you could place your virtual objects right away in our real world. Videmus shows that this vision can be realized even today. The Videmus client runs on smartphones currently available. As soon as Videmus is started, you can see the device's camera picture on screen. Here you are able to place virtual content. Placed contents can now be found and viewed by anybody who has a Videmus-capable device. The flexible content concept allows to integrate whole applications into the environment. This node, for example, can be manipulated directly. Additionally, contents can be grouped in categories to help users to keep the overview. Each user can choose which contents he wants to be displayed. Of course, most properties of the contents can be changed subsequently. Technically, Videmus consists of three components. The smartphone component establishes the user interface and allows insertion, view and manipulation of contents. The server stores all the contents and delivers them to all connected smartphones depending on their location. Last but not least, the support system supplies the compute power to do a visual environment analysis based on the smartphone's camera pictures and to calculate the poses for displaying the contents. For developing Videmus, we invested quite some time beside the project preparation phase to create a future-oriented and extendable design, which allows us to adapt the system to more powerful hardware. Due to the fact that the Videmus components run on 3 different platforms, we invested a lot of effort in building up a fast and stable communication package, which supports different programming languages. We need a 3-dimensional representation of the current environment of the smartphone to integrate content seamlessly into the camera picture. The creation and use of this representation is core of Videmus. To analyze the environment, we first have to extract feature points from the camera pictures. Then we have to bring them into relationship with features from other pictures with other camera poses from the temporal environment. With this information, we can determine the 3-dimensional positions of all features. Those are used as environment descriptor. Our environment descriptor can now be matched with another descriptor of a content stored on the server. This way, the camera pose relative to a content can be determined much more precisely than with the exclusive use of location data.